A chemist needs 5 liters of 50% salt solution. All she has available is a 20% salt solution and a 70% salt solution. How many liter of each of the two solutions should she mix to get a 50% solution? This is about strength of solution, and saying it's a 50% solution means that 50% of this object is salt. Right? Actually, I'm kind of abusing the concept here. I think really there's when you say 50% salt solution, that means there's the maximum amount of salt that you can dissolve in a solution, and compared to that, it's 50%. But it turns out that even if you just change that into saying 50% of this 5 liters is salt, as if salt was like fluids, it'll just work out. Okay. Now, there's something that I want to tell you about percentages. When you say 50%, what does this mean? 50%. What does cent mean?
50 over 100?
Yes, exactly. Cent means century, 100 years, right? Cent means 100. Per means divide. So that means it's 50 over 100. So you should really write down 50% as 0.5. Okay. Same goes on for other problems. When you have like bank interest and stuff like that, when you see percent, it's easier if you just convert that to a regular number by dividing by 100. Okay? All right. So, the way I'm describing this is the following. I'm just saying that 0.5, when you say 0.5 solutions, this is like the percentage of the salt per the fluid. Right? So we have the strength, the salt, and the fluid in this question. And once you identify those units, then you just put that on a table, and then you start filling that in, then you're going to get an equation. Right? So let's do that. So there's the strength of the solution, there's the salt, and there's the fluid. And in mixture problems, you usually have 3, because you have the mixture. Okay, so there's the 20% salt solution, and there's the 70% salt solution, and there's the mixture. That's how you write the table. The 20%, of course, has a strength of 0.2, because 20% is 0.2. 70% is 0.7. What's the desired strength of the mixture? 50%, so it's 0.5. Okay. What else can we fill in this table? Is there any number that we didn't make use of here?
5 liters.
5 liters. Where does that fit in?
Fluid.
Huh? It's the fluid, but which of the 3 should I put?
Mixture.
The mixture. It's the mixture that we want. Put the 5 there. Okay. All right, and if you look at the question, it says how many liter of each of the 2 solutions should she mix? So it's about asking about how much of these. So if I put X here, I should be able to write something here. What should I put here? What should I put there? Okay, let's think of it like this. If we had like 4 liters of 20% solution, how much of the 70% solution should we put there?
1.
We should be putting 1. How do you get 1? If this was 4, you put 1. How do you get?
Minus X.
5 minus X. That's how we're doing it, right? So we put 5 minus X. Just a little bit of thinking can tell you that should be 5 minus X. Okay. So we got that, and then we have this whole bunch of empty spaces, and it's about the salt. That's the one that we don't know.
And multiply the fluid.
The fluid should be multiplied both sides. So these are canceled, and you get salt equal to, this is a strength, sorry, this should be strength. So strength is salt over the fluid, but you multiply the fluid both sides, and you get salt means you multiply the strength with the amount of fluid to fill this in. So we're going to do that. So multiply 0.2x. This will be 0.7, 5 minus x. 5 times 0.5, that's 2.5. Okay. Now, because these are 0.2 and 0.7, 0.5, these are ratios. If you have ratios, you don't have the additivity. You can't add, so it's like this. If you mix, I guess with beer, beer and alcohol, it's easier to understand, right? So if you mix 30% alcohol, let's say it's a vodka or something, with 6% alcohol, say beer, do you get 36% alcohol? No, you don't. Okay, you never do. Anybody who's drinking knows that, right? You get a weaker solution than 30%, of course, right? So if you add strengths, you don't get the resulting strength. That doesn't work. However, the content of the alcohol itself will be added. The content of the water or everything extra should be added, right? When you mix two things, there are things that do get added. Do you agree? Right? I mean, when you mix beer and vodka, the alcohol content doesn't go away. They get added. The water gets added, right? So everything else gets added. So salt, you add these and you get that. Fluid, you add these, you get that. Okay? Now this is already true. X plus 5 minus x equal to 5. Is this true? Should be true, right? But we don't have that. So this is the equation that has to be satisfied. So what we do is we write down that equation which says 0.2x plus 0.7 5 minus x should equal to 2.5, right? Just like that. 0.2x, 0.7, 5 minus x. Add these two things, it should equal to 2.5, right? And then you multiply 10 both sides and you get x plus 5 minus x. No, sorry. Multiplying by 10 gets rid of the point, right? 10 times 0.2 is just 2x. 10 times 0.7 is just 7. 10 times 2.5 is 25. And I like that because I don't like decimals. It's harder to work with. You have 2x. 7 times 5 is 35. 7 times x, negative 7x, equals to 25. 2x minus 7x is that's negative 5x. Subtract 35 to both sides, it's negative 10. So what do you get for x? 2. What's the unit? X is here. What's that?
Liters.
It's fluid.
Liters.
Yeah, liters. L. Okay, what's the other one? 5 minus x, what's that? 3. So the answer is that 2 liters of the 20% one and 3 liters of the 70%. If you mix these two together, you get a 5 liters of 0.5 or 50% solution.